Hello everyone, this is Oscar and this video is on lesson 5.1 about mid-segment theorem and coordinate proofs. So first things first, mid-segments. The mid-segments of a triangle are the segments that connects the midpoints on any two sides of the triangle. It is worth noting that there will always be exactly 3 mid-segments in a triangle, not more or less. The figure on the left shows all 3 mid-segments of the triangle ABC and mid-segments DE, EF, and FD. So along with the definition comes with a theorem. It became a pattern or something. The mid-segment theorem states that the segment connecting the midpoints of 2 sides of a triangle is parallel to the third side and is half as long as that side. It sounds confusing, but it basically means that the mid-segment is parallel to the side of the triangle that it isn't in contact with and is half of the length. On the right, the mid-segment DE in that triangle is parallel to OC, the side that is not touching, point D being the midpoint of segment OB and point E being the midpoint of segment BC. And that's all in this theorem. Makes you wonder why the mathematicians made this a theorem at all. Again, this became a pattern. An example would be the famous kitty toy kaleidoscope, or whatever. It's the barrel that kind of looks like a monocular, but there are mirrors and paper flicks in it, so it sometimes makes beautiful patterns. In this particular scope, the pattern makes up triangles and segments that happen to be mid-segments. Triangle ABC has the mid-segments DE, EF, and FG. The way the kaleidoscope works is that there are mirrors that are placed in symmetric patterns, so one side will be the same as another. The word kaleidoscope derived from 3 ancient Greek words: kalos, meaning beautiful, eidos, meaning seen from, and scopio, meaning to examine. Therefore, the translation is the observation of beautiful forms. I'm not really sure how to pronounce them, so on to the next one. Some of the streets in town happen to be a triangle, and a valley happened to be the mid-segment of Peach Street and Cherry Street. Once again, proving geometry is everywhere and that there's no hope of running away from it. All hail geometry! Onto the coordinate proof, which is the way to support an argument by having a plane with generalized points on it. Self-explanatory. The way to do coordinate proof is to place the figure on the plane, having the lower left corner or vertex on the origin. Makes it easier to bound it. As you can see, point A of triangle ABC is on the origin. The variables f, g, and d is the distance away from the origin, and that way we can know the length of the side in an instant. However, we have to use different variables for a rectangle. K represents how many y units the figure is away from the origin, and h is how many x units. The next part would be proving the mid-segment theorem on our own. Of course, this is from the textbook, but anyways. Here we are trying to find the midpoints of the triangle sides OB and BC. The process is listed on the left, and as you can see, we are left with points D and E. Oops, there's an error. The second equation is supposed to be the coordinates of point E. So if you would subtract the 2 coordinates, you can see that the length would be P0. That is exactly half the length of OC, which is 2P0. And we've done it. And that's all on lesson 5.1, and tell us what we could have improved on. Thanks for listening through the whole thing.